Welcome to today's video. In this video I'm going to continue looking at square roots and cube roots, and in today's video I'm going to talk about prime factors. I'm going to define what prime factors are, and I'm also going to demonstrate how you can find prime factors of the given number, okay, or numbers. So watch this video up to the end, as I'm going to share with you the knowledge of prime factors and how to find prime factors. Okay, let me start by defining factors. I'm going to start with the definition of factors. So you need to know what a factor is before you know the prime factors. Okay, so a factor of a number is a number that divides exactly into that number. So a number is said to be a factor if it can go into another number without leaving a remainder. Then that is a factor. Okay, for example, I have got 4. 1 can go into 4 without leaving a remainder. 2 can go into 4 without leaving a remainder. Hence, 1 and 2 are factors of 4. But 3 is not a factor of 4, because when I divide 4 by 3, it will give me 1 with a remainder of 1. So since it leaves a remainder, that means it's not a factor of 4. Okay? So that is a factor. It's a number that can divide a number without leaving a remainder. Now, what is a prime factor? So a prime factor of a number is a number that divides exactly into that number and it has only 2 factors. Okay, so now we are looking at types of factors. So a prime factor is a number that is a factor of another number, whilst itself it has only 2 factors. Okay, or in other words, we are saying a prime factor is a factor which has 2 factors. Okay, so here we are talking about 2 numbers. There is a number and then there is another number. For instance, I've got 4, like I said earlier on. Then I have also 2. 2 is a factor of 4. 2 can go into 4 without leaving a remainder. And when we look at this 2, which is a factor of 4, 2 has only 2 factors, which are 1 and itself. So 2 has only 2 factors, which is 1 and 2. So 2, we can say 2 is a prime factor of 4, because 2 has only 2 factors. Okay, the other example I can give you is example of if I have 6 and 3. 3 can go into 6 without leaving a remainder. But 3 can go into 6 without leaving a remainder. Well, 2 has also 2 factors. 3 has also 2 factors. 3 can go into 6, but 3 also has only 2 factors. 3 is a factor of 6 and it has 2 factors. Therefore, 3 is a prime factor of 6. Okay, you are going to understand this well when I start finding prime factors of the numbers. I'm going to work out 3 examples. Okay, so let's find prime factors. So we're going to use these 3 numbers to find the prime factors. So the instruction is list prime factors of the following numbers. Okay, so number 1 we have got 6, number 2 I've got 12, number 3 we have got 30. So what we're going to do first, we're going to find factors of these numbers. factors. We are not going to find, we're going to find the factors, all the factors, whether it's a prime factor or not. We're going to list all the factors. Okay, so we'll start by pairing them. I'll be listing them in pairs, like expressing 6 as a product of two numbers. So that's what I'm going to do. To find these factors, I'm going to be expressing 6 as a product of two numbers. Okay, so 6, we can say 6 is equal to, so we can multiply 1 by 6 and it will give us 6. So we're going to write 1 by 6, which will give us 6. Then we can also multiply 2 by 3, will give us 6. So 2 by 3. Okay, now as you can see, 4 cannot go into 6 without leaving a remainder, as well as 5 cannot go into 6 without leaving a remainder. 6, we have already used it. So we are saying 6 has got 4 factors. Okay, now these are the 4 factors. Now let's look for numbers among these factors which are prime numbers. So if you don't know we don't know prime numbers, we have a video where we talked about composite and prime numbers, where we listed composite numbers between 1 and 30, as well as prime numbers between 1 and 30. So you can check on the video so that you can also see how you can identify prime numbers. So here the prime numbers we have, okay, the prime numbers are numbers which have got 2 factors. So when we look at first, we start with 1. 1 has got 1 factor. It's not a prime number because it just have 1 factor. When we look at 6, 6 has got 4 factors. As we can see, we have listed them. 6 has got 4 factors, so it's not a prime number. When we come to 2, you find that 2 has got 2 factors, which is 1 and 2 itself, so it's a prime number. When you also look at 3, 3 has also 2 factors, which are 1 and 3 itself, so it's also a prime factor. So in this example, from these factors we have listed, we can say 2 and 3 are prime factors. The one I've circled in green and yellow there, they are prime factors. So we can say 2 and 3 are prime factors of 6. Okay, 2 and 3 are prime factors of 6. So those are the 2 prime factors of 6. Okay, if you have got questions, you can ask them in the comment section. Otherwise, we go to question 2. Question 2 is 12. So we need to list first the factors of 12. All the factors of 12, whether they are prime factors or not, we are going to list them first. Then we are going to identify the prime factors from those factors which we list. So we'll start by using 1. So we can multiply 1 by 12, it will give us 12. What I'm trying to do is I'm trying to express 12 as a product of 2 numbers. So 1 by 12 will give us 12. 2 by 6 will give us 12. And 3 by 4 will give us 12. Okay, so 4 we have used it. So 5 cannot go into 12 without leaving a remainder. 6 we have listed already. 7 cannot go into 12 without leaving a remainder, as well as 8 will leave remainder, and 9, 10 and 11 will leave also remainders. So which means we have listed all the factors of 12. So now we need to identify the prime factors of 12. So as you can see, I talked about 1. It has 1 factor, so it can be. 12 has got 6 factors. 6 has got more than 2 factors. 4 has got more than 2 factors. So 2 and 3 are the ones that have 2 factors, like we saw in first example. So 2 and 3 there are the prime factors of 12. So 2 and 3 are prime factors of 12. So 12 has got prime factors which are 2 and 3. Okay, so as you can see, 6 and 12, they have got the same prime factors. Now we can go to question number 3, which is 30. Question number 3, they're asking us to find the prime factors of 30. So we are going to do the same thing we have been doing. We'll start pairing or maybe writing 30 as a product of two numbers. So we can start with 1 by 30, which will give us 30. Then 2 by 15. Then, 3 by 10. Okay, 4 cannot go into 30 without leaving a remainder. 5 will go into 30. How many times? 6. So we're going to write 5 times 6. Then 7 will leave a remainder. When we divide 30 by 7, we'll leave a remainder. And 8 will also leave a remainder. So 9 will also leave a remainder. So basically, these are the factors of 30. Okay, these are the factors of 30. So 30 has got 8 factors. So we will start looking at prime numbers now of these factors we have listed. So 1, we talked about 1, which is 1 has only one factor, so it cannot be a prime number. 30 has more than 2 factors, so it's not a prime number. 15 has got more than 2 factors, as well as 10 has got more than 2, and 6 also has got more than 2 factors. So as you can see, 1, 30, 15, 10, and 6 are not prime numbers. But when you look at 2, 3, like we saw earlier on, these are prime numbers. So even 5 is also a prime number. When you look at 5 has just 2 factors. So since it has 2 factors, it's a prime number. Therefore, we can say 30 has gotten these 3 numbers as its prime factors. So 30 has got 3 prime factors, which are 2, 3, 5. Okay, so we can say 2, 3, and 5 are prime factors of 30. So those are the prime factors of 30. So basically, this is how you identify prime factors of given numbers. If you have got questions, you can ask in the comment section. Otherwise, thank you so much for watching. It has been easy learning Z Mathematics. The future is bright. See you in the next video, and God bless you.